Well, here are the answers to the questions on rotational motion. Most of it does not require any explanations, so just go through those. Number 2, find the angular velocity from which you find the linear velocity. Then find the radial acceleration or the centripetal acceleration. In number 3, here you find the initial angular velocity and the final, and calculate the angular acceleration. And therefore, after 2 seconds, assuming that it's the same acceleration, you can find the new angular velocity, using which you can find the radial acceleration and the tangential acceleration. This is where you have to use another equation that does not involve time, and remember that it's slowing down, and so angular acceleration is negative. And also in the B part, use the formula angle is equal to average angular velocity multiplied by time. In question 5, you have to first convert the kilometer per hour into meter per second, then use each of these velocities to find their angular velocities, and then again, as before, find angular acceleration. And in the B part, use omega is omega naught plus alpha t to find the time. In number 6, the torque is Rf sine theta. Theta is 90, so find F. And then there are 6 points, therefore the force is 2000 newtons. In number 7, the moment of inertia is mr squared, and to maintain the angular speed, the torque needed is the same as that by friction, but in the opposite direction. And therefore, the applied torque can be calculated. Number 8, remember that the moment of inertia of a cylinder is the same as that of a disc, because the height does not matter. So find the moment of inertia and then find friction using torque is I alpha. And to maintain the motion, you have to overcome the friction. So the net torque is going to be the sum of the applied and the friction. In number 9, the moment of inertia of a rod about an axis through its center is ml squared by 12. But if the axis is about one end, it's ml squared by 3. And because there are 3 of those, you multiply it with 3. Hence find the total moment of inertia and then use tau is I alpha after finding alpha. Number 10, the total kinetic energy is the sum of the rotational and the linear or translational. And because it's a sphere, moment of inertia of solid sphere is 2 by 5 mr squared, which gets you 7 by 10 mv squared, and plug in the numbers to find the answer. In 11, it's coming rolling down, so the potential energy at that height gets converted into the total kinetic energy. So as before, the total kinetic energy is 7 by 10 mv squared, and from that you can find the velocity, using which you find the angular velocity. Uh, 13 is about conservation of angular momentum, where I1 omega 1 is I2 omega 2. And therefore the rotational inertia has increased by a factor of 1.6. Again, 14 is all same concept. Therefore the moment of inertia too is less, and that is accomplished by pulling our arms to the center of our body. 15, angular momentum is I times omega, and I is mr squared by 2. Find omega as 2 pi f and multiply them to get about 14 kilogram meter squared per second. And also in the B part, torque is dl by dt, rate of change of angular momentum, gives you negative 2.8 meter Newton. In 16, because the person is walking radially, there is no external torque, so the angular momentum is conserved. Therefore the angular momentum of the platform should be then equal to the angular momentum of both platform and the man. Set them equal and find omega 2 is 1.2. Obviously it has slowed down. And then you can find the initial kinetic energy of rotation, 1/2 I omega 1 squared, and likewise find the final. And you see that the final kinetic energy is less. 17, again it's conservation of angular momentum. Second case, there are 4 people. Each one has that moment of inertia times 4 gives you the total, and then you got to add it to the moment of inertia of the merry-go-round. So the second case, and it's considerably slower now at 0.48 radians per second. So thank you. I hope you could pause it and then look at each slide and study for the exam. Thank you.